Imagine trying to send a letter without an address. You write a heartfelt message, seal it in an envelope, and drop it in the mailbox. But without an address, it has no destination. It would be impossible for the postal service to know where to deliver it. The letter would just end up lost, undelivered, and forgotten, piling up with countless others. In the vast digital universe of the internet, computers use a special language to communicate with each other. This language ensures that data packets, much like our letters, reach their intended destinations. This language is known as the TCP/IP protocol suite. TCP/IP stands for Transmission Control Protocol/Internet Protocol. It is the fundamental communication protocol that allows different devices to connect and share information seamlessly. And just like our physical addresses, computers use IP addresses to find and communicate with each other across the web. An IP address is a unique string of numbers separated by periods, like 192.168.1.1, that identifies each device on a network. When you send an email, stream a video, or browse a website, your device sends data packets to the destination IP address. Routers and switches along the way ensure these packets are directed correctly, much like postal workers sorting and delivering mail. But how do we remember all these IP addresses? That's where the domain name system, or DNS, comes in. DNS translates human-friendly domain names like www.example.com into IP addresses, making it easier for us to navigate the internet. Security is also a crucial aspect of this language. Protocols like HTTPS ensure that data transmitted between your device and a website is encrypted and secure, protecting your information from prying eyes. Firewalls and other security measures act as gatekeepers, monitoring and controlling incoming and outgoing network traffic based on predetermined security rules. They help protect our digital communications from cyber threats. The language of the internet, with its protocols and addresses, enables billions of devices around the world to connect and communicate. It is the backbone of our digital age, making global communication and information sharing possible. So, the next time you send an email or stream a video, remember the intricate language working behind the scenes, ensuring your data reaches its destination. The internet's language is a marvel of modern technology, connecting us all in ways we never thought possible. Every single device connected to the internet needs a unique IP address. This is crucial because it ensures that data is sent to the right destination. Without unique addresses, the internet would be a chaotic mess of misdirected information. Imagine receiving emails meant for someone else, or trying to watch a movie but ending up on a random website. An IP address is a string of numbers that uniquely identifies a device on a network. Think of it as a unique digital fingerprint for your computer or smartphone. These numbers are not random. They follow a specific format called dotted decimal notation. This format makes it much easier for humans to read and remember IP addresses. Dotted decimal notation represents each of the 32 bits of an IP address as a decimal number, separated by dots. For example, a typical IP address might look like this: 192.168.1.100. Each of these four numbers can range from 0 to 255. This format is much easier to remember than a long string of zeros and ones. Section 5. The two halves of an IP address. Every IP address has two main parts: the network part and the host part. The network part identifies the specific network the device belongs to, similar to a zip code. The host part identifies the specific device within that network, like a street address. This hierarchical structure ensures that data is routed efficiently across the internet. Section 6. Classifying the addresses. To manage the vast number of devices on the internet, IP addresses are divided into 5 classes: A, B, C, D, and E. Each class serves a different purpose and has a different range of addresses. Classes A, B, and C are the most commonly used for public internet addresses. Section 7. The range of IP addresses. In this section, we will delve into the different classes of IP addresses and their specific ranges. Understanding these ranges is crucial for network management and efficient data routing. Each IP address class has a specific range of addresses determined by the first few bits. These bits are essential in identifying the class and, consequently, the purpose and size of the network. The IP address classes are divided into 5 categories: A, B, C, D, and E. Class A addresses start with 0. This class is designed for very large networks, such as those used by major international companies or large-scale service providers. The range for Class A addresses is from 0.0 to 127.255.255.255, allowing for millions of unique addresses. Class B addresses start with the bits 10. These addresses are used for medium-sized networks, such as those found in universities or large businesses. The range for Class B addresses is from 128.0.0 to 191.125.255.255, providing a substantial number of addresses for sizable networks. Class C addresses start with the bits 110. This class is intended for smaller networks, such as those used by small businesses or home networks. The range for Class C addresses is from 192.0.0 to 223.2555.255.255, offering a more limited number of addresses suitable for smaller scale operations. Class D addresses start with the bits 11 and 10. These addresses are reserved for multicast groups, which are used to send data to multiple destinations simultaneously. The range for Class D addresses is from 224.0.0 to 239.255.255.255, and they are not used for standard host-to-host communication. Class E addresses start with the bits 1 and 11. This class is reserved for experimental purposes and future use. The range for Class E addresses is from 244.0.0 to 255.2555.255.255. These addresses are not assigned to any specific organization and are typically used for research and development. This classification system allows routers to quickly determine the class of an IP address and route data accordingly. By understanding the class of an IP address, network administrators can efficiently manage and allocate IP addresses within their networks, ensuring optimal performance and connectivity. The ability to distinguish between different classes of IP addresses is fundamental to the design and operation of modern networks. Section 8. Special addresses for special purposes. Classes D and E are reserved for special purposes. Class D addresses are used for multicast, which allows a single message to be sent to multiple devices simultaneously. This is useful for applications like video conferencing or online gaming. Class E addresses are reserved for future use and are not currently used on the public internet. Section 9. More special addresses. In addition to the 5 classes, there are also special IP addresses that serve specific functions. These include private addresses, used within local networks like your home or office, loopback addresses, used by devices to communicate with themselves for testing purposes, and limited broadcast addresses, used to send messages to all devices on a local network. Section 10. A universe of information awaits. In this chapter, we embark on a journey through the vast and intricate world of IP addressing, a fundamental concept that underpins the very fabric of the internet. Just as the stars in the night sky form constellations, IP addresses form the backbone of our digital universe. Understanding IP addressing is fundamental to comprehending how the internet works. Each device connected to the internet, whether it's a smartphone, a tablet, or a computer, is assigned a unique IP address. This address acts as an identifier, allowing devices to locate and communicate with each other seamlessly. Imagine trying to send a letter without an address. It would be nearly impossible for it to reach its destination. Similarly, without IP addresses, data packets would be lost in the vast expanse of the digital world. It's the invisible force that connects billions of devices and enables us to share information, communicate with each other, and access a world of knowledge at our fingertips. From browsing the web to streaming videos, from sending emails to video calling loved ones across the globe, IP addressing makes it all possible. It ensures that our digital interactions are smooth and efficient, bridging the gap between distances and bringing the world closer together. In the next part of our journey, we'll delve deeper into the fascinating world of subnetting and explore how IP addresses are further divided to create efficient and scalable networks. Subnetting allows for better organization and management of IP addresses, ensuring that networks can grow and adapt to the ever-increasing number of devices. We'll learn about the techniques and strategies used to divide networks into smaller, more manageable segments, and how this contributes to the overall efficiency and security of the internet. So, get ready to dive into the technical yet intriguing realm of subnetting, where we'll uncover the secrets behind the seamless connectivity we often take for granted.